In the last video, we talked about the 3 different kinds of decay processes. And one question that you might have come up with was, how long do those decay processes take? And the answer is it completely depends on exactly what is decaying. So as an example, I believe we wrote an equation for polonium that decays by or by alpha decay. And in that particular case, that particular decay process, almost all of that radioactive polonium will be gone in about 1,000th of a second. So it goes really, really, really fast. On the other hand, though, carbon-14 undergoes beta decay. And you may have heard of radioactive dating, carbon dating, to try to determine the age of different kinds of, age of fossils, age of those kinds of things. And while I could say a whole lot about radiocarbon dating, I will just, for today, I'll just suffice it to say that radiocarbon dating is not a very accurate way to date anything that's very old, just because of changes that have occurred over in the environment over the past millennia. So at any rate, if you have a carbon-14 atom and it is undergoing beta decay, that will take 50,000 years until all of it has decayed. So as you can see, on the one hand, I've got an entire sample that decays in less than a second, and then on the other hand, I can have something that takes tens of thousands of years in order to decay all of the way. And so we measure the rate at which these elements decay by their half-life. And half-life basically just says it's the length of time that's needed for half of the atoms in a sample to decay. So you can almost think of it like this. If I have a handful of pennies and I toss them all up in the air and I let them all hit the floor, there's no way that I know, let's say that I put a little dot on one of the pennies, there's no way that I'm going to know for sure if that particular penny is going to land heads or tails. But it would be a relatively good guess to say that if I have 10 pennies in my hand, probably about half of them, about 5, are going to land heads, and about the other 5 are going to land tails. Now, it may not happen exactly that way, but in general, about half of them will land heads and half of them will land tails. And so that's the same type of thinking that we have to use when we're talking about half-life. I have this huge sample of atoms, and there's a 50-50 chance that either an atom will decay or that it won't decay. And I can't pinpoint the atoms and say that one's going to decay and that one's not, but about half of them are likely going to decay. You're actually going to be doing a lab in the next several days that is going to hopefully help you understand what this decay process really looks like. So today, though, we're just going to work a couple of sample problems with half-life. And so the same paper that you had for the day 2 sample problems, we're going to use that now for the day 4 sample problems, and we're going to work through a couple of these radioactive decay problems. So the first problem says a radioactive isotope with a half-life of 2 hours is used in scientific research. If a scientist starts with 1,000 grams of the isotope, how many grams will be left in 8 hours? Now, the thing that you have to remember about half-life is that half of it is going to decay, and then the next radioactive period that you have, the next time period that you have, half of that one decays. And then half again is going to decay. So it's not like it's just going to take, if a half-life is 2 hours, it's not like it's all going to be decayed in 4 hours. If you have this handful of coins, and if I have 10 coins and I toss them up in the air and let them land on the floor, and I pull out all the ones that are tails, then I've got to pick them all up and I got to toss them again. Well, now how many of them have landed tails and how many of them have landed heads? So it's the same type of question that we're asking. Just because half of them are going to decay doesn't mean they're all going to decay the next time around. They still only have a 50-50 chance of decaying, just like if I was going to flip a coin. So in this particular incident, when everything starts, I have 1,000 grams of this radioactive substance, and that is when I am actually at 0 hours. The clock is just now starting. So the half-life is 2 hours. So 2 hours into my process, about half of this is going to decay. So I'm going to go from 1,000 grams down to 500 grams. Okay? Another 2 hours into the process, I'm now going to be at T equals 4 hours. Half of this is now going to decay. Again, it's like here, if I had 1,000 pennies and I tossed them all up in the air, about half of them would land tails, so I pull them all out. Now I'm going to take the 500 pennies that I have left, I'm going to toss them up in the air again. And now which ones are going to land up tails? And I get to pull those out. So half of this will decay, so that's going to get me down to 250 grams. All right, so that's at 4 hours. What happens if I go another 2 hours and I'm up to 6 hours? Well, if I take 250 and I divide it in 2 again, that gets me down to 125 grams that I have left. Okay, let's go another 2 hours, because the question said how much is going to be left after 8 hours. And so after 8 hours, I divide this in half again, and I get down to 62.5 grams. So all I did is divide these numbers in half every time. Okay, so that is a reasonable expectation of what's going to be left after 8 hours. Now I want you to notice, it takes me more than 2 half-lives to get rid of all this. I'm still not rid of all of it. And it's going to take several more half-lives until I basically get down to nothing. Eventually, you know, you have 1 atom left, eventually the thing's going to decay and it's all going to be gone. But just because you have a certain number of half-lives, that's also going to mean that only half of it's going to decay each time. All right? Let's look at the second problem that's there on your paper. It says the half-life of iodine 131 is 8 days. So this one has a much longer half-life than the first sample that we looked at. If you start with a 40-gram sample of iodine 131, how much will be left in 24 days? So let's kind of redo our little table here. All right, so I'm going to start with 40 grams of iodine 131 when I am at 0 days, okay? The half-life is 8 days. So in 8 days, half of this is going to decay. So that's going to get me from 40 down to what? I'm going to divide that in half, so I'm going to have 20 grams left in 8 days. So if I go another half-life, how many days is that? Well, another 8 days is going to put me at 16 days. And this is going to go down by half, so my 20 is now going to go down to 10 grams. And the question said how much is going to be left in 24 days. So if I go 8, 16, if you know how to skip count, this is easy to do. 8, 16, another 8 days puts me up at 24 days, which is what the question actually asked me for. And so now I'm going from 10 grams, I'm going to split that in half again, and I'm down to 5 grams. So 5 grams is going to be the amount that is left after 24 days. It will have gone through 1, 2, 3 half-lives at that point. All right, so I've given you guys some more problems to work. You can work those problems, and now you can get really good at half-life.